All right, so we'll pick up with what we didn't finish in 5.4 yesterday. So we had just gone through all the formulas for vectors. Okay, for adding, subtracting, scaling, and magnitude. The magnitude formula is really what theorem again? It's the Pythagorean theorem. It's just the hypotenuse of a triangle. All right, so let's look at a little bit of a concept of unit vectors. So remember that if a vector's magnitude is equal to 1, then it's a unit vector. So you should already have that in your notes. But the idea is, what we're going to do is we're going to be given a vector that's not a unit vector, and we're going to turn it into a unit vector. To do that, you are not allowed to change the direction. All you are allowed to do is lengthen or shorten it to make it exactly 1 unit long. So does anybody remember what kind of product we called that to lengthen or shorten a vector? What was the name of that product? Yes? The scalar product, because we're scaling the vector. All right, so let's say that I had a vector that was, the length was 7. What could I divide that by to change it into a length 1? 7. Or I could multiply it by 1/7. Okay. What if I had a vector that was 10 units long? What could I scale it by to turn it into 1 unit long? 1/10. So the idea is you find the length of your vector and you scale it by the reciprocal. If it's 10 units long, multiply by 1/10 and it'll shorten it to 1. If it's 6 units long, multiply it by 1/6 and that would turn it into 1. So to find a unit vector, if they give you a vector that's not a unit vector, all we're going to be doing, and I just said this earlier, you're going to find a vector that points exactly the same way, except it's longer or shorter, whatever it needs to be to come out to 1 unit. And there's 2 ways you can think about it. So the way Ryan said, you multiply by the reciprocal of the length. So if it's 6, multiply by 1/6. If it's 10, multiply by 1/10. Or if you don't want to think of it as multiplying by the reciprocal, just think of dividing it by its length. 7 divided by 7, 1. 10 divided by 10, 1. So divide by its length or multiply by the reciprocal. So U stands for unit vector. So to find a unit vector, take your vector and divide by its length. Or the way someone else said, take the vector and multiply by the reciprocal of its length. Same thing. Okay. Remember, these are all vectors, so they're bold. Or if you want to put the little arrow on top, that's fine too. So first thing you got to do when they give you a vector is figure out, is it already a unit vector? Maybe it already has a length of 1, you don't have to do anything to it. If it doesn't have a length of 1, then we'll plug it into this formula and see what we have. Okay. Does everybody have the formula to find a unit vector? So it says, example 3, find the unit vector for 3i minus 4j. Okay. In order to find the unit vector, Tyler, what's the first thing I'm going to have to figure out so I can plug it into that formula? Do you know what it looks like, what you're trying to describe? With the lines. What's that called when you put the lines around it? The what?
Magnitude.
The magnitude. Let's find the magnitude of v first. Okay, so we start out with square root. And Chad, can you remind me how how I find the magnitude, what I plug in?
X1 squared and Y1 squared?
Yep, so x1 squared plus y1 squared. What's x in this case?
3.
3 squared?
9.
Yep, we'll do that out. And what's y squared?
16.
Yep.
4.
Does it matter if you include the negative or not?
No.
No, because if you're going to square it, it's going to go away anyway. So we get the square root of 9 plus 16. Okay, so how long is this vector? Yep.
5, but also in that formula, is it always going to be adding regardless of sign?
For the Pythagorean theorem?
Yes.
Yeah, Pythagorean theorem is always adding. Yep. So we don't have a unit vector. This vector is how many times too long?
5.
It's 5 times too long, so we have to make it 5 times shorter. So what do we scale it by?
5. So 1/5.
1/5. So we're going to do 1/5 of that vector. Okay. What would that give me if I multiply 3 times 1/5?
So you would just flip it?
Did I flip it? 3 negative 4? No.
No, I'm talking about the 5. Like, I
Oh,
don't
the scale?
understand why you get to 1/5.
Because the vector is 5 units long.
Mm-hmm.
So you have to scale it by a fraction to make it shorter. If it's 5 units long and you scaled it by a whole number, it would get bigger.
Okay.
So we have to scale it by a fraction to make it smaller. So 1/5 will make it exactly 1 unit. Yep.
Would it just be 3/5
3/5, yep.
over negative 4/5? I mean, never mind, then negative 4/5. Like
Comma,
negative
yeah.
4/5.
Oh, so you have to reduce it like that? You can't just leave it like the 1/5 outside?
Yeah, you got to do it up.
Okay.
So that would be your vector. Or if you wanted to write it with I and J, 3/5 side minus 4/5 J. So there's a vector, it points exactly the same way as the other one. All we've done is we shortened it, so it's exactly 1 unit long. Okay, do you always scale it by the reciprocal of the length? That's how you can remember it. Okay, any questions on how we did that one? All right, so unit vector. The last two things last thing we're going to look at in this section is a application. There's 2 applications. One of them is velocity. The other one is what's called static equilibrium. I'll explain static equilibrium, like the idea of it, really quickly, but we're not going to do a problem. We're going to do a velocity problem. So if you use a vector to represent the speed and direction of an object, that's the velocity vector. Now, how do you think we could describe the direction of an object? Like if we were throwing an object. Like if you're traveling, you might use north, south, east, west, but we don't usually describe an object like if you throw it to someone, say, well, he threw it to me at a, in a northwesterly direction. How would you describe the way you would throw something as a direction? Could you, I'm looking for a very precise way to describe it, like exactly how it left your hand.
Can you give me the first letter of the word?
Straight.
Depends on how you describe it. You could use different words to get at the same idea.
Forward.
How forward though? Like I could throw it forward to you like up
Straight.
or straight or down, but more specific.
Forward.
Exactly the direction to you. How could I?
Pinpoint. I don't know.
Accurate. Aiming.
Okay, and if you're going to aim, let's say you were aiming a cannon or something that's shooting something. What do you think the adjustment, when you adjust the aim, you're adjusting the what?
The angle.
The angle, right? You're adjusting the angle. So when we're describing how we're throwing something, you throw it at a certain angle, or it's fired at an angle, and then it releases at a certain speed. Okay? Okay, and that's a velocity vector. All right, let's look at this. So here we have a vector that represents an object that's traveling. Okay, so it's been released. We're not going to account for like curvature or anything like that. Let's just assume it's like a ray of light. It just travels in one direction, this object. Okay. First thing I want to do is I want to find the angle. Okay, the angle that I release it at. And to do that, what shape could I make out of that ray? Yeah, we're going to make a triangle. So I'm going to draw a vertical and just put it right there. Any question on that? Now, by creating a triangle, what we can figure out here is two things. That and that. What are those two things that I just drew in red? They're the what of the vector?
The size.
Okay, it's kind of the sides of the triangle, but they're begins with a C.
Components.
They're the components of it. This vector has a horizontal component and a vertical. In this case, the horizontal's right, the vertical's up. I just want to use the same letters. Okay. So for the angle, I used theta in the formula. They're going to use alpha. Doesn't really matter. Okay, let's call this component the y component because it's the vertical, and the x component. If you want to describe that vector, the way you describe a vector is the horizontal, comma, the vertical. So we just have to figure out a formula for x and a formula for y. All right, let's start with x. We're going to find a formula for x, and we're going to use the two things that we know. What trig function do you think I could use here that would involve x and the side that's labeled v? Yeah? Yeah, cosine. Because cosine is adjacent over hypotenuse. So the cosine of my angle equals adjacent. Now x is the length from here to here. Just want to make that clear. Y is the length from here to here. Okay, so cosine of alpha equals adjacent over, and what goes in the bottom? Just in general for cosine. What is it? Hypotenuse. Now, can someone tell me what is x again? The length, right? Is v the length of that side?
No, you need to find the magnitude of it.
I need the magnitude of v. So that's important when you write it. Because we're talking about lengths when you deal with a triangle. So x is the length of the bottom, magnitude of v is the length of the hypotenuse. Now, how would I get x by itself? What would I multiply by?
Magnitude.
Magnitude. So x is the magnitude of v, that would be how fast you throw the object, times the cosine of the angle you throw the object at. There is your horizontal component. That could go right there. That's the first part. And now we're going to do the same thing for y. What trig function do you think I could use to find y? Sine. Sine of alpha equals, what's sine again? What over what? Opposite over hypotenuse. So opposite in this case would be, how much? What is it? Y. And the hypotenuse? Magnitude of v. Yeah. And now we'll do the same thing to get y by itself. So the vertical component of this vector is the magnitude of v times the sine of the angle. Thanks. And now you plug that in right there. So there's two ways you can write a velocity vector. You can write it with the angle brackets, and it would look just like this. Magnitude of v, cosine of your angle, comma, magnitude of v, sine of your angle. That's one way. Did anyone remember the name of the way with the i's and j's? What was that called? Yeah?
The eyes were for the left or right,
Yeah.
and it was like eyes, a vector 1 unit long facing to the right,
Yeah.
and then J is a vector 1 unit long facing up.
Right. So the other method that's called unit vector method, using the i's and j's. Well, the first number is your I, the second number is your j. So magnitude of v, cosine alpha, whatever that number is, that would go in front of the I, plus magnitude of v, sine of alpha. Whatever that number is, that would go in front of your j. Now, if you look at that, what do we have written twice that we could shorten it up and only have to write it once? The magnitude of v. It's like it's been distributed to each one of them. So if we wanted, we could put it on the outside and shorten it to just this. Magnitude of v, cosine alpha with an I, plus sine alpha with a j. And that last one, that's most of the time how you're going to see it written. So that's the formula for a velocity vector. You could write it the other way too. That's fine. Either way, but that bottom way is a little more simplified. And that's exactly what we just came up with. So you're going to be given two things though. Okay. The initial speed that you throw the object at, that's what I just underlined in red, and the angle you throw the object at. That's what I underlined in green. So angle the object is thrown at, and initial velocity. And all you have to do is fill into that formula. That's it. Okay, so again, we have another formula that's really just based off Socotoa. Just a right triangle, finding the length of each side using sine and cosine. Okay, any questions on the formula? Okay, so let's try an example. Okay, so we have an object traveling 50 miles an hour at an angle of 30 degrees. So the first thing they want us to do is find the velocity vector. But they tell us to do it in unit vector form. Okay, so when I gave you guys these formulas right here, I said you could do it that way. That's algebraic. That's what your book calls that way. That's unit vector. So we have to do it like the bottom one. Okay, so let's find it first, and then we'll look at, once we have our answer, what does each part really mean? Okay, we've already kind of talked about this before. So what do we start with? To find a velocity vector, the first thing we need,
Numbers.
yeah, the magnitude. What's the magnitude of the object here?
50 miles.
50 miles an hour. 50. And then we put parentheses. And what's the I component?
Cosine 30.
Cosine 30. Cosine 30. That's my I.
Sine 30J.
Plus sine 30. J. That's the answer in unit vector form factored. Okay. What could we do with this 50 though and simplify it a little more? Yeah, we'll distribute it out. 50 times cosine 30, write that down. And then 50 times sine 30. All right, on my calculator, switch my mode to degrees. And we've got 50 cosine 30. Okay, so I get 43.30. 43.30. And what letter is next to that? I. Plus, did you hit enter? And then sine 30. Did anyone have that one? What's 50 times sine 30? Uh, 50 times sine 30?
25.
25. And what letter goes with that?
J.
J. So that's a velocity vector. Now it says to explain the meaning of each component. What is that 43.3? If you think about the object actually like traveling, you want to tell me what that is? Well, the direction is the 30 degrees. So that's my direction. But what's the 43.3?
Speed.
What speed? It is speed.
It's speed of the angle is going in. I don't know. Something.
The speed of the object, what? Well, the speed is 50 miles an hour. We know that, like, if it's a 50 mile per hour speed at a 30-degree angle. So,
Oh, it's the speed of the, like, the beginning of it, when you first do it.
okay, so this, you might think like the object is going to slow down because of air resistance as time goes on. Let's assume that the speed never slows down. So we'll assume that there's no air friction, just to keep it simple. The I and the J are the what of the vector. They're the,
X and Y.
which are the, begins with a C.
Components.
The components, right? The components of the vector. So that 43.3 is a speed component. Yep.
I'm sorry, I wasn't really paying attention. So did you say just multiply the 50 by the cosine 30?
Yeah.
Okay.
So what speed is that, 43.3? It's the speed of the object. Kate?
The speed of the object. I don't know.
The speed of the object what? And what is the first component of the vector? What is it? What is it? It's the horizontal, okay. So what is that 43.3?
The speed of the horizontal.
Yes.
Oh,
It's the
it
speed
really
of the
is.
horizontal. So if I was standing in front of you and you threw an object at me 50 miles an hour at an angle of 30 degrees and I had a radar gun and I'm standing right in front of you, the radar gun would say the object is coming at me at 43.3 miles an hour. It's not coming at me at 50 because some of your speed was to throw the object up. You didn't throw the object straight at me. And then the 25, that's the speed of the object in the vertical. So if I was up above you, I'm in like a helicopter, and I had a radar gun and I pointed it down, the ball would be coming up at the helicopter at 25 miles an hour. Right? So that's the speed in each direction. Another way to think of it is if you threw an object at a wall 50 miles an hour at a 30-degree angle, it would hit the wall at 43 miles an hour. If you were indoors and it happened to hit the ceiling before it started coming back down, it would hit the ceiling at 25 miles an hour. Assuming that, again, a couple things. We're ignoring gravity because gravity is going to slow it down, and we're ignoring wind. That's going to slow it down too. But if you did this in outer space, no gravity, no wind, what I just said is exactly what would happen. We'll say far away from a planet.
Okay.
But you're right, yes, there is gravity if you get close to a planet. Yeah.
There's not a lot though.
Doesn't everything have gravity to an extent?
Anything that's massive, yes.
Jupiter has a lot of gravity.
Does it though? Because it's mostly gas.
Maybe all the way up to 30.
It's what it says.
So the first number, speed in the horizontal direction. Second number, speed in the vertical. Okay. Any questions on that idea? Finding a velocity vector and then explaining what each component means.
So you kind of explained that's how you're doing it.
Yeah, yeah. All right, so the second thing that we're not, still copying?
Yeah.
We're not going to look at in depth is called static equilibrium. The idea of static equilibrium is you have a weight and it's suspended from two cables and you find the tension in each cable. And you might say, well, isn't the tension in each cable the same? No, it depends on if the cables are the same length. So if you had a 200-pound object and you put a 4-foot cable on one side and a 1-foot cable on the other, you'd have something like this. The tension in each cable is not the same. It's not the same. So the goal with static equilibrium is to find the tension in each cable. Not super hard, but again, not a problem we're going to look at. I chose to do the velocity one because it's a lot quicker.
Is this going into 5.5 now?
Yep. Now we're going into 5.5. All right, so things we've done with vectors so far. We've added vectors together, both with numbers and visually, drawing it out. We've subtracted vectors. What else have we done with vectors besides add and subtract them?
Multiply?
In what way? Scaled them. We multiplied a vector times a number. This is the first time we're going to look at how do you multiply a vector times a vector. And I'll mention this a little bit later, but there's two ways to do it. Did I mention that yesterday? Okay, when you multiply with numbers, there's only one way to do it. 3 times 2 means to take 3 and add it to itself twice. 3 plus 3 is 6. Well, when you multiply with vectors, there's one way called a dot product, and there's one way called a cross product. So if somebody said to me, take the vector x and multiply it by the vector y, I'd have to say, can you be more specific? How do you want me to multiply? Dot product, cross product. One of them you can do in 2D and 3D. This works in both. Cross product only works in 3D. So we can't look at that one yet because we haven't done anything in 3D. Okay? Okay, so suppose we had 2 vectors. Okay, I'm going to show you the formula for the dot product. Vector v has a I and a j component.
Is that A1?
Yep, a1 and b1. And vector w also has a I and a j, or a horizontal and a vertical component. In an actual problem, a1, b1, a2, and b2 would be all numbers. Okay, so a1, a2, b1, b2, all numbers. Okay, so the formula to find the dot product, very straightforward. You take a1 and a2, You multiply them together. You're going to take B1 and B2, multiply them together. Then you're going to take those two things and add them. And that's the dot product. So the product of A1 and A2 plus the product of B1 and B2. And the way you write it is with a dot.
Dog to sign back in.
Yes. Okay, so when you want to write the product of two vectors, make sure you put the dot. Don't put two letters next to each other. That means nothing with vectors. We're not doing it right now, but if you wanted to know what cross product looks like, it looks like that. You put an X. So most of the time in math, we don't use X to mean multiplication because it could look like a variable. Well, with cross product, you do. You put a small X. Okay, so what's A1? What did I say up above? That's a number. A2?
Number.
What's a number times a number?
Number.
A number plus another number. So what's a number plus a number?
A number.
A number. So the point here, when you do the dot product, the answer
A number.
is a number. It's not a vector. So when you do a dot product, you might get an answer of like 7. What that number means, I'll explain later on. For now, I just want you to practice a dot product.
You need a dot between the A1 and A2 too?
No, because that's a number times a number.
Okay.
In the convention for writing a number times a number, you can just put them next to each other. Yep. You can put parentheses if you want, you know, however you want to indicate multiplication.
Alright.
Okay, so we've got 2i minus 3j and 5i plus 3j. Okay, to find v dot w, that's how you say it, v dot w, what would be the first two things I would multiply?
25.
Yep, 2 times 5. So I would just write it like that. Plus, next two things,
-3
times 3. 2 times 5 gives me 10. -3 times 3 gives me 9. So what's the dot product?
1.
1. And again, what does that number mean? Well, it means something, but we'll look at that later. Any questions on how we did v dot w? Okay, let's try the other way. Bless you. Bless you.
Thank you.
Okay, w dot v. What would I multiply in the correct order to do w dot v?
3. Not negative, the positive times 3.
Well, I just want to know how I would write it first. 5 times 2.
Oh,
Remember, you always start with the x components, then the y components. So 5 times 2 plus
3 times -3.
3 times -3.
So you get the same answer.
Yes.
So it doesn't matter which way you put it as long as you have the X's.
If it's the same.
I mean,
What does that mean?
it doesn't matter where you
The
have it.
point is what that means.
It's the same thing.
It's the same thing. So what does that mean about the dot product? It's
It's
commutative.
that's
I was just gonna say they're the same.
Yes. So the dot product is commutative. When we get into cross product, it's not. That'll probably be one of the first times you've ever done multiplication, and when you switch the order, you don't get the same answer. So dot product is commutative. That's the point. Any question on that? Right, so let's try v dot v. Okay. Dotting v with itself. Okay, so if I wanted to find v dot v, what would I multiply?
2 and 2 and -3 and -3.
Yep, 2 and 2. -3 and -3.
4 plus positive 9.
Which is?
13.
13. So that's like doing 2 squared plus 3 squared.
Negative 3 squared.
Yeah, 2 squared plus negative 3 squared. When else did we do that? Like something squared plus something squared.
Right there, right there.
And that was to find the,
The third side, which would be c squared.
and what is that of the vector? It's the
Magnitude.
magnitude. The only thing we didn't do here is take the square root. So this number is almost like the magnitude. Something squared plus something squared, but it doesn't have the square root. Let's see if that works on W.
If we did square root it, would it be the magnitude?
Yes, the square root of 13 is the magnitude. Yep. And I'll write that in a second. W dot W. Okay, how would you do that one? So 5 squared plus 3 squared. The only thing you're not doing is taking the square root.
It's going to be 36.
So 5 squared plus 3 squared gives me
25 plus 9 equals 36.
25 plus 9 equals
36.
Wait, no, 34. My bad.
34. So dotting a vector with itself is kind of like finding the magnitude, but that's actually the magnitude squared. You didn't take the square root of it. So dotting a vector with itself doesn't give you the magnitude, because you didn't take the square root. It gives you the magnitude of it squared. Same thing with W dot W. Any question on that? Dotting a vector with itself gives you the magnitude squared. If you were to take the square root, then you would have just the magnitude. Right, so there's a connection between a dot product and what we've done before, the magnitude. That's the connection right there. Okay, let's try this one. I want to dot the vector 2, 6 with 0, 0. Okay.
It's going to be 0.
What's the calculation?
2 times 0 plus 6 times 0.
2 times 0 plus 6 times 0. And what's the answer?
0.
0? Can you be more specific?
When I multiply 2 and 0. Wait.
Vector 0.
Is it the vector 0?
No, it's a dot 0.
No.
The what 0?
I don't know.
It's 0 because.
What kind of 0?
It's the number 0,
vectors. Number 0.
not the vector.
Not the
I'm
vector.
so confused. There's too many. I didn't know there was a 0.
There is, yes. So remember, when you find a dot product, the answer is a number. So that's the number 0. Just the regular number you're used to. When you do something like 0 times, let's just make up a vector. Okay, that's a bold W. 0 times W. That is the vector 0. Why? Because when you multiply a number times a vector, the answer is a vector. When you do a dot product, the answer is a number.
You threw me
Do you
off.
have to put that line above?
You could do it either way. Technically, you only need to make it bold. Or if you don't want to make it bold, then yes, you need that on top.
Yeah, you threw me off. Because, like, you had me second guessing. I was like, wait, something times 0 is 0, right?
Yeah.
'Cause
I just wanted to make sure people understand this is 0, the number. The answer is not a vector. Okay. Any question on that? Okay.
Next.
So, dot product works with distributive property. If it ever came up in a problem, you are allowed to do that. U dot V plus U dot W. And if you look at that and you say, well, yeah, isn't that just the distributive property? You can't assume that the distributive property works with a dot product.
Looks like we're gonna go on a website.
A website? It does?
Yeah,
what?
a little bit.
www.maxiloves.math.org.
U dot V dot plus W equals
What are you saying?
www.u.w.org.
Okay, there you go.
www.mrhager's period
Oh, there goes this video.
class of math.
Show off.
All right, so dot product, again, it's distributive. Whether or not that's going to come up, I mean, it's up to you. I think doing a dot product twice would be more work than just taking two vectors and adding them first, and then doing the dot product. But technically, you can do it either way. Okay, so distributive property works.
I thought U equals unit vector.
In this case, you can just represent a generic vector. If you want to change it to like X and Y, whatever you want to use. But yeah, U is usually unit vector. The only letter they're really careful about using, Ryan, is I and J. They'll never use I and J because those ones are really special. All right, so the whole point of the dot product, what the dot product allows you to do is find the angle between two vectors. Now, if I had, say I just have a piece of graph paper, and let's say I had that vector and that vector. Could you find the angle between those two vectors right now without what I'm about to show you?
Probably not.
It'd be very difficult to.
Yeah.
Approacher.
You have to be as smart as me.
Oh, yeah.
I like the answer with scores now.
How could you find the angle between those two vectors? What do you think you'd have to do?
I mean, I don't know how right now. Yeah.
Angle side.
Okay, what would the distance formula tell you?
Like those two sides.
Sure, we could find the length of those two sides. So,
all three sides.
what do you mean 3? I don't see a third side. Yes.
Yeah.
If you made a triangle out of it,
You know.
you could find the coordinates of all those points. If you can find the coordinates of this, this, and that, you could plug it into the distance formula and get all the distances. So you would have a triangle where you know all the sides.
I forget the distance formula.
Something like that. Now, if you know all the sides, what law can you use to find any angle you want?
Any of
Side, side, side is the law of
cosine.
cosines, yes. So technically, you can do this problem with stuff I've already taught you. It'd be a lot of work, though. You'd have to find the distance between all the points. So you'd have to find all three sides. And then use the law of cosines. But you could. You could figure it out. Or there's a formula that has this already built into it. And the proof of it, if we were going to go through the proof, uses the law of cosines. That's kind of where the cosine comes from.
Lots of formulas.
So this formula says to find the angle between two vectors, the cosine of the angle equals the dot product over the product of the magnitudes. So 3 things you have to find. Dot product, the length of the first vector, and then the length of the second vector. And then if you can find those 3 things, plug them into this formula, and you can find the angle. That's a lot faster than using the law of cosines in the distance formula 3 times.
Yeah.
A lot faster. So the denominator, that's the length of u times the length of v, but you should already know what those symbols mean.
The demon?
Denominator,
Oh.
yes.
Did you not?
Okay, so we're going to look at a problem where we have 2 vectors, and I want to know the angle between them. So 3 things we have to find. The dot product, so we'll start with that. Then we have to find the length of each vector. Okay, can someone tell me calculation to find the dot product?
4
Yep.
times 2
All right.
and -3 times half.
Anything between them?
Yes. A plus sign.
Plus sign. Okay, So what's 4 times 2 plus negative 3 times 5?
8 plus 15 is 9. 24. Well, there's a negative, so we have to take that into account.
Yes.
8 minus 15.
8 minus 15.
So what am I reading?
7.
Negative 7. Okay, so that's your dot product. What else do I need to use this formula?
2 magnitudes.
Yep, I need the 2 magnitudes. So let's start with the length of u. Okay, u. It's going to be the square root of what plus what? Well, Joe?
4 squared and negative 3 squared.
Perfect. Square root of 4 squared and negative 3 squared. 4 squared gives me how much?
16.
16. Cole, negative 3 squared?
9.
9. 16 and 9, that's the square root of 25, which means u is, the magnitude is 5 units long. There's the length of u. And the last thing we need is the length of v. So we got 2 squared gives me
4.
5 squared,
25.
and 25 plus 4,
Square root of 29.
square root of 29. Even if that could be reduced, I don't really care because that's not the final answer. Now we have what we need to fill in the formula. What trig function does the formula use? Cosine. So the cosine of my angle equals, what goes in the top?
7? Yeah. Negative 7.
Negative
Oh,
7.
negative 7.
Yeah, the dot product, but yep, we're on the right track. And then in the bottom, 5,
5 square root of 29.
square root of 29. Now, if I do out the right-hand side, is that my angle?
Would you have to take the inverse cosine?
Yeah.
The right-hand side is the cosine. So take the inverse cosine of everything on the right-hand side. Let's see what you get. I would just take that all in at once. Degrees is good. Inverse cosine of negative 7 divided by 5 square root of 29. I think if you type it in like that, it should be okay. It should be fine. Yep, 105.07. That's the angle between the vectors. Now, technically, if you draw 2 vectors, there's 2 angles. Right? There's the one inside, and there's the one outside. We're always finding the one inside. Okay, the shorter, the one that's less than 180. Okay, any questions on how we got the angle? Now, that's nothing special. 105.07, that's just a random number. But sometimes the angle does come out to something special. Anybody have a guess what would be considered a special angle between 2 vectors?
45.
9.
90. Yep.
30.
And if 2 things form a 90-degree angle, they are
Perpendicular.
perpendicular. So that's the first one we'll talk about.
180.
We'll talk about 180 in a second.
180, 270, 360.
So when they talk about 2 vectors being perpendicular, you can use the word perpendicular, that's fine. But most of the time they use the word orthogonal. It means exactly the same thing. It's just a word they use with vectors. Just there to confuse you. Don't get confused. So in the test, if the directions say, are the following vectors orthogonal? It just means, are they perpendicular?
Wait, how do you say it again?
Orthogonal.
Orthogonal.
Yeah, that's what I was orthogonal.
Yeah.
Feel like
Just put the emphasis on the wrong syllable.
oral.
Or roll the word. Now you let me on.
So now, when I'm asking if they're orthogonal, I'm going to use the upside down symbol from geometry that looks like a T, meaning perpendicular. So if the vectors are orthogonal, what does that mean the angle would be?
90.
90. So let's work backwards and see that there's actually a shortcut to do this. If the vectors come out to a 90-degree angle, somehow the dot product divided by the product of the magnitudes, and you get an angle of 90. Okay? So I'm kind of working backwards saying, let's start with something that's perpendicular and see what happens on the right-hand side. Let's take the cosine of 90. Someone on their calculator type that in?
Yes.
What's the cosine of 90?
It is 0.
0. So, if you have two vectors that are perpendicular, somehow that fraction is going to equal 0. How can a fraction equal 0?
There's a 0 in it?
If
Where?
top.
In the top. The only thing that matters for a fraction to equal 0 is if the top is 0. It doesn't matter what the bottom is. What's in the top of our fraction?
0.
Well, 0, but that's the
Dot product.
dot product, exactly. So if you find the dot product between two vectors and it comes out to 0, that would make the top 0, which would make the entire fraction 0.
Would that mean that one of the vectors is a 0 vector?
No, not this. No, it doesn't have to. Ooh, I'll show you. Okay, so the shortcut, if two vectors are perpendicular, their dot product is 0. Because that makes the numerator 0, which makes the whole fraction 0, and the cosine of 90 is 0. Technically, the 0 vector, if you find the dot product with the 0 vector, you always get 0. So technically, you could say the 0 vector is perpendicular to everything. But I'm not really sure if people say it that way because the 0 vector isn't really a vector.
Then what is it? A 0?
It's like, well, it's considered a vector, but I guess a little more accurate, it's a vector without any magnitude or direction. So if a vector has no direction and magnitude, how would you even draw it? We usually put a point.
Then how is that a vector?
Well, it's a special vector.
It's
Just like you run.
Can it spin it?
I'm not a special vector.
No, you can't specialize.
Just like you run.
Okay,
Okay, now you're the special vector.
so let's see if these two vectors are perpendicular. Okay, what's the shortcut to check if they're perpendicular?
To see if their dot product's 0.
Yep, what's the dot product here?
2 times 1 plus 2 times 1.
2 times 1 plus
2 times 1 times 2. No.
J times
1
Yes.
times 2.
Mhm. So those plus those. So we got
4.
So, are those vectors perpendicular?
No.
No.
Heck.
What could you change there to make them perpendicular?
subtract.
One thing. So what would you change?
Big word and negative.
Yeah, make anything a negative, and they would automatically be perpendicular. If you're like, well, what would you make a negative? Anything. The 2, the 1, the other 2, or the other 1. Let's try. We already did that. Okay, so an example, you would ask me, does it always have to be a 0 vector? If you had 2i plus 3j and negative 2i, let me pick a nicer number. 1 and 4. If you found the dot product there, it would come out to 0. 2 times negative 2 is negative 4. 1 times 4 is positive 4. So if you drew those, they are perpendicular. But neither one of them is the 0 vector. And you could sketch it. Just a really quick sketch. Right 2, up 1. And then left 2, up 4. Left 2, up 4. Do those kind of look perpendicular?
Yeah.
Yeah. They should be. If I used graph paper, they would have come out exactly 90. Okay, so perpendicular is a special case, and then the last one. What do you think is another special case?
180.
180? And what do you think that would be?
Straight line. Or what, dot product?
Well, what do you think that would mean if the vectors have an angle of 180?
Means they're like the same.
They rotated more. I don't know. What do you think?
Anyone think about from geometry, you usually study these kind of lines in the same section. Perpendicular
Horizontal.
and
Oh, parallel.
parallel. So
There you go.
could have two vectors like that, which have an angle of 0 between them. If you line them up, angle is 0. Or two vectors like that have an angle of 180. Either way, those are both parallel. Those are parallel vectors. Okay, so two vectors are parallel if the angle between them is 0 or 180. So let's try the same thing. Let's see if we can come up with a shortcut for when this works. Okay, so what's the first angle we said? If they're parallel, they could be what angle?
0.
0. So the cosine, if they came out parallel, this is one situation. The dot product over the product of the magnitudes comes out to 0 somehow. What's the cosine of 0?
90.
1.
Oh,
What is it?
1.
1.
wait, so if the cosine of 90 is 0, shouldn't the cosine of 0 be 90?
No, inverse. You're thinking inverse.
Oh, okay.
Yeah. So how can this happen? How can a fraction come out to 1?
Like you have 1 over 1.
Equal to the bottom.
If what?
The top is equal to the bottom.
Right. So it's not as nice of a shortcut because he said if the top equals the bottom. Well, then that means I have to know the top and I have to know the bottom. I have to find both. Okay. So it's not like the last time. So that's one thing that could happen. Top and bottom are the same. What's the other angle we said is parallel?
270?
180.
Yeah. I don't even know.
So somehow you do your dot product over the product of the magnitudes and you get an answer of 180. What's the cosine of 180?
1.
Is it also 1?
Nope, it's not 1.
2. 0?
I don't have a calculator.
You don't have a calculator? What's the
I'm just
cosine of
throwing
180?
out numbers
I
right
got it.
Kid. So,
It
Pi
is
over 4.
negative 1.
Negative 1.
Oh. You know what? That hurt my feelings.
So how can a fraction come out to negative 1?
If you have a negative on the top or bottom.
But there's a negative on the top and then the bottom, but that doesn't come out to 1.
Okay,
Negative.
you have the same thing on the top and bottom, but one's negative, or yeah. But if both's negative, then you might as well just call it 1. you
Yeah.
know? So
So they're
you want
opposites.
Negative sign somewhere.
Yeah.
Yeah.
So
I don't know what.
if the top and the bottom are opposites, then you would get negative 1. Unfortunately, that means you still need to know the top and you still need to know the bottom. You have to find both. Okay, so let's look at our last one. Okay, so determine if those vectors are parallel.
I'm gonna go with
Yes.
yes.
You think so?
I think so,
because the
I
last
believe
one
so.
wasn't parallel.
They're
this
very
one
so if you multiply like
is
b
that-
by 5, I mean you get w. So I'm gonna go with yes.
All right, let's see what happens.
I bet you 5 times it's yes.
Yes.
What's the first thing we need? What's the numerator? That's the dot product. So 4 times 20
80.
and 5, negative 5 times negative 25. 125. So what's the dot product?
205.
So, for these to be parallel, what am I hoping the bottom comes out to?
Negative 205.
Negative 205 or
Or 205.
205. If the bottom comes out to one of those two numbers, then I'm good. Okay, let's find magnitude of v. So it's going to be the square root of
4. Yeah.
4 plus 20?
Yeah.
No, 4 squared
4
plus
squared
20
plus-
squared.
4 squared
So 16.
Negative 5 squared.
plus negative 5 squared.
Oh, that's what it is.
So what's that? The square root of 41. Enough. And magnitude of w. 20 squared.
400. Right? Yeah.
Yep. 400. Plus, what's negative 25 squared?
I can do that in my head. It's 625.
So that's the square root of how much?
1025.
Good. So the denominator is the magnitude of v times the magnitude of w. Well, let's multiply those together and see what the denominator would be. So square root of 41 times square root of 1025. So we get
Oh.
205. So if you got that and you're like, you know what, I still don't recognize what's happening, plug it into your formula. What was the dot product? 205. What was the product of the magnitudes? 205. When you divide them, what do you get? 1. And how would you get theta by itself?
Yeah.
Yeah, if you take the inverse cosine of 1, watch what you get. Inverse cosine of 1, 0. And we said if you get an angle of 0, it's parallel. So was the question, are they parallel? Yes. They are parallel.
Does it work like that in like all cases? Like if the top like it was here and then it's like both the sides are like multiplied by 5 or whatever number? Like does it work the same way every time?
Yes. Yep. Yep. Okay, so for homework, everybody has the one from last night, part 2. Yep, I can put it up if you need it. Okay, so there's the first part. And second part.
Is this one's due, Wednesday?
Yeah, so this one is Wednesday, and then this one could be Wednesday or Thursday, but then the one I give you tomorrow is definitely due Thursday. So you can choose when you want to do page 352. And you know what, just 7 through 17. We're going to skip 25. Okay, so we'll take a look at that tomorrow. And I know it's been a lot of stuff because now we did 3 lessons in 2 days. So tomorrow will be a good review of everything. Should be a lot easier than the past couple of days.
So we get candy?
Candy? No, I don't have any candy.
So does it all have
Sorry.
to be on